Hi, today we're going to learn about the last form of quadratic equation that we're going to study, and it's called factored form, and it's y or f of x, which is synonymous with y, is equal to a, and a is the same value no matter what form you write an equation in. A just it tells us if it's positive, the graph opens up. If it's negative, the graph opens down. If it has an absolute value greater than 1, the graph is narrower vertically. If it has an absolute value like this one, less than 1, the graph is wider than the parent function vertically. So the form is we have a, and then we have two binomial factors, x minus root 1, x minus root 2. So when you see an equation in this form, there is a simple way to graph it without having to multiply these out and convert it into standard form. Just work with this. This tells you where the x-intercepts are going to be. So if you wanted to know where on y you are when a line or a curve crosses the x-axis, the moment that it hits the x-axis, the value of y must be 0, right? Because y is positive up here, y is negative values down here. But right at the moment that you cross the x-axis, y is equal to 0. So basically, if you set this equal to, a 0, and you look at this, the negative 1/4 tells us, first of all, that no matter what these equal, that the graph is going to open down because it's negative, and it's probably going to be kind of wide. So I'm expecting something like this. So to find the factors, I find if the equation is equal to 0, what value of x makes this factor equal to 0? And that would, of course, be a positive 7. And what value of x makes this factor equal to 0? Therefore, the whole thing would be equal to 0. And that is a negative 1. So say that positive 7 and negative 1 are our x-intercepts. Okay, another name for those is the zeros of the function or the roots, root 1, root 2, root 1, root 2, it doesn't matter. So we're going to plot those points on the coordinate plane here. So I'm at negative 1 on the x-axis, so negative 1, 0. And I'm over at 1, 2, 3, 4, 5, 6, 7. At 7, 0. So the x-intercepts here, I'm just going to, they're negative 1, 0, and the ordered pair 7, 0. Now, the beautiful thing about parabolas is that they're perfectly symmetrical. So if I have 2 points like this on the same horizontal line, then the axis of symmetry must be dead center between those two. If we look at how far apart negative 1 and positive 7 are on the number line, they are 1 plus 7, or 8, apart from each other. Half of 8 would be 4. So I can move 1, 2, 3, 4 to the right of that point, or 1, 2, 3, 4 to the left of that point, and I will hit a midpoint. Now, sometimes it's easy to see and sometimes it's harder. So let's look at how we would do this. This will find us the vertex and the axis of symmetry. So to find the vertex, the x-coordinate of the vertex is the average between negative 1 and positive 7, between the two zeros or roots. So to find the average, I add them together. Remember, it's root 1 plus root 2 divided by 2, which in this case is 7 plus negative 1 divided by 2, which is 6 over 2, which is 3. Okay, so that tells me that the vertex is, the x-coordinate of the vertex is positive 3. It also tells me where the axis of symmetry is. So at 1, 2, 3, I'm right here, and I'm just going to dash in my axis line. And label that axis of symmetry is the line x equals positive 3. Okay, so now I know my vertex is on here. I know that it has to be above these points because I already looked at this, and because this is negative, tells me the parabola opens down. So I know that up here somewhere is my vertex, but I don't know exactly where. So whenever I found an x, it's so nice because all I have to do is plug that value into the original function for x, plug in a 3 here, and here for x and find what y is when x is 3. So the y value will be equal to -1/4 times, I would put a 3 in for x, 3 minus 7, and I put the 3 in for x here too, times 3 plus 1. So this is -1/4 times 3 minus 7 is -4, 3 plus 1 is +4. So -4 times +4 is -16. And when I multiply that by -1/4, it's like 16 divided by 4. I get a +4. So my vertex now is at 3, 4, at that ordered pair. So I'm going to come up here and go up 1, 2, 3, 4, and label that on the graph. Okay, so that's going to be, right now, I already know that the parabola is going to open like this, and I'm going to have a maximum value. And the maximum value is going to be y equals 4. So that's going to be my maximum. So that's 4. My domain will be all real numbers, meaning it's all the possible x values. And the range where y can go, I know that this is going to open down. It's never going to go above y is 4. There's never going to be a y value, no point up here. It's never going to turn around. If this is a maximum, then y can be any value less than or equal to 4. Okay, now I'm just going to want to get, maybe I want to get one more guide point. So I'm going to put in, I'm going to choose an x value, just 1 to the right over here, 2 to the right, maybe. Just split that difference and hope that it lands on a whole number. So 2, yeah, it will, because this is a whole and this is whole. So 2 to the right would be 5, where an x is 5. So when x is 5, y is equal to -1/4 times x minus 7 times x plus 1. So in this case, it would be -1/4 times 5 minus 7 times 5 plus 1. So 5 minus 7 is -2, and 5 plus 1 is 6. Okay, and I still have a -1/4, and this is a -12. So -1/4 times -12 is going to be a positive 12 divided by 4, or 3. So I know that ordered pair is on here, so I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. So that point 5, 3 is on the graph, and I can reflect it. I am 1, 2 to the right of the vertex of the symmetry line, and so I go 1, 2 the other direction. And that's going to give you enough guide points to sketch in kind of a wide curve that's going infinitely downward. Some of you people are just putting endpoints on these. These don't stop. It's not a V, it's a curve, and it goes on forever. You have to have an endpoint showing that. Okay, so anyway, intercept form. Find the midpoint between the two roots. Draw on your axis line when you found x, okay? And then plug that value in. I'll plug that value in to the function and solve for what the y value of the vertex is. So anyway, thank you for coming, and I'll see you in class.